Good morning, everyone. Hello, and thank you for joining the webinar today. We're going to give folks just another minute to log in, and we'll be starting soon. Okay, let's go ahead and get started. Good morning to all our attendees, and welcome to today's Better Buildings webinar. Dedicated to bringing you the latest actionable insights from leading industry experts, Better Buildings webinars are a chance to explore the topics, technologies, and trends that affect your organization, as well as efforts to accelerate decarbonization and energy efficiency adoption. So today's webinar is called Quality on Tap, Water Reuse Technologies. Before we dive in, pun intended, there are a few housekeeping points I'd like to cover. So please note that today's webinar will be recorded and archived on the Better Buildings Solution Center. We'll follow up when today's recording and slides are made available. Next, all attendees are in listen-only mode, meaning your microphones are muted. If you experience any audio or visual issues throughout the webinar, please send a message in the Q&A box located on the bottom of your Zoom panel, and our tech support team will be in touch. Next slide, please. My name is Sarah Stubbs, and I'll be your moderator today. I'm an ORISE Fellow at the U.S. Department of Energy's Building Technologies Office, and I'm excited to talk about water conservation and reuse. We'll go on to our agenda slide. So we'll start off with some polls, just kind of see who's in the virtual room today. We'll go on to our speaker presentations, and then we'll have a robust portion of time for Q&A, hopefully at the end, where the audience will be able to submit questions. All right, so why don't we go on to our polling? So today we're going to be using an interactive platform for Q&A and polling. So please join us in this. You can go to www.slido.com on your mobile device, or you can open a new window in your internet browser. Today's event code is pound or hashtag DOE. If you'd like to ask our panelists questions, please submit them anytime throughout the presentation. We'll be answering your questions near the end of the webinar. You can also select the thumbs up icon for questions that you like, which have already been submitted, which will result in the most popular questions moving to the top of the queue. So please open up Slido and check that out so you can submit questions and see what questions other folks have as well. So we can go on to our polls. So we want to learn more about you. So let's start off with a few polls. So if you're over at slido.com, you will now be able to respond to the following questions. And if you're having any issues, please do. All right, lost me there for a second. I am back. I was going to say, so hopping right back into the polls. So it looks like we've got a lot of industrial folks on the line today, which is fantastic. See a lot of state government as well as a fair number of contractors or consultants. Federal government, that's where I'm coming from, multifamily, and then nonprofits and non-government organizations. Some utilities, but by far over 30% of our attendees today are industrial. So that's awesome. And we do have two fantastic organizations, including Saint-Gobain, which is an industrial organization, of course. And yeah, looks like a lot of government folks. So why don't we move on to the second poll? So this poll is asking our attendees today, so how knowledgeable are you about strategies and tools for water reuse in your industry? Anything goes here, you know, but this really does help our panelists and presenters think about how they can tailor their presentations to you. So it looks like about half of the folks on the line are saying they have some knowledge. they're somewhat experienced. And then we have about equal between no knowledge at all and very experienced or inexperienced. And we see 0% are very experienced, which is great because we have some very experienced speakers today to talk about these topics. But it does look like the vast majority of folks have some knowledge, some experience, but then we also have some folks who are new to this, and that's awesome because we're going to be able to cover the ground level, like the ground floor of what's going on, as well as to get into some more specific projects. Awesome. So why don't we go on to our third poll today? Hope you all are enjoying the polls. So at the specific facility or portfolio that you operate or work in, which water conservation or water reuse systems do you have in place? And you should be able to check multiple on this. So you can show us all that apply. And these are getting into some details here. So it's okay if your organization doesn't use any of these, or if you don't know. But for those of you who are aware, tell us about it. So answers rolling in. It looks like a lot of folks use interior water conservation systems like low flow toilets. I know that can be really important in the multifamily space, for example. So that's over 60% of our attendees are saying that. And we also have exterior water conservation systems, a lot of irrigation elements, as well as wastewater treatment elements. It's very important in the industrial space. Yeah, a lot of folks using those interior elements, followed not very closely by exterior water conservation systems. And then lots of elements of that wastewater treatment. So great, this is really exciting, and I'm really glad to see so many of you are aware and active in this, and we're going to get into some details of it today. All right, thank you so much for being part of our polling. I think we can go on. And so before we get into our speakers, I'm going to give a quick overview of the Better Buildings, Better Plants Water Savings Network. So water and energy are interdependent. Water is used to produce nearly every major energy source, and energy is critical to transporting and treating water. We call this relationship the water-energy nexus. And it's why the DOE cares about water. Energy and water are very closely connected. So if you go on to the next slide, so this water energy nexus led us to create the Water Savings Network. This is a network of Better Buildings, Better Plants partners that participates in peer exchange activities and gains recognition for their work to conserve water through their operations. So through this network, partners across many sectors can track a water reduction goal across all or a portion of their portfolios. Network members have the opportunity to receive technical guidance, be connected with peers, and demonstrate their water-related solutions. If you join the Water Savings Network, your organization commits to participate in tracking and reporting your water data and participating in Better Buildings water-related activities like peer exchanges and publishing case studies. Next slide, please. So we're really proud of this. Between 2015 and 2022, Water Savings Network partners saved over 16 billion gallons of water, and many of them have set and achieved water-based goals as well. Next slide. As you can see, we also have many network members across all sectors of the Better Buildings, Better Plants program. And if your organization is not already part of this program, we would love to see you up here too. And so my contact information will be up at the end of this webinar. Please reach out to me if you're interested. Next slide, please. So as I mentioned, one opportunity through the Water Savings Network is to publish a solution or case study about your work in water conservation. Next slide. These solutions can take various forms. I won't go into a lot of detail here, but again, these slides will be published later so you can dig into it, or happy to talk about it live. But these different forms of case study really can be tailored for what your organization needs. So this can be a very detailed implementation model, a showcase project focused on just one facility, or a blog style solution at a glance. Next slide, please. So another opportunity through the Water Savings Network is to pursue a water savings goal to demonstrate your leadership in this space. Next slide. A few more details here and some examples of what these goals can look like. So we do encourage network members to set a water use intensity goal with a baseline within the past 3 years. These goals can also either focus on your entire portfolio or a specific portion of your portfolio. However, the network is open to individualized conversations with network members so that we can discuss what makes the most sense for what your work is. Next slide, please. This slide just shows an example of a Better Buildings profile for a Water Savings Network member who has set a goal. So we'll show your goal and baseline year as well as your progress over time toward goal achievement. And this can be a really great way to demonstrate market leadership to your peers and then also contribute to the body of case studies on water conservation. And it also is a great reputational opportunity if you have a water savings program as well. And with that, next slide, we are going to go on to our 2 presenters today. We have an awesome lineup. We'll be hearing from Peter Fisk of NAWI and Robert Urich of Saint-Gobain. Thank you to both of you for being with us today. Next slide. So our first speaker today, as I mentioned, is Peter Fisk, the Executive Director of NAWI, the National Alliance for Water Innovation, the Department of Energy's Desalination Innovation Hub, tongue twisters, headquartered at Lawrence Berkeley National Lab. Funded for 5 years and $110 million and recently renewed for a second 5-year term and an additional $75 million, the NAMI research program to radically cut the cost, energy, and greenhouse gas outputs from water treatment and reuse. Prior to joining LBNL, Peter was the CEO of Pax Water Technologies, which was acquired in 2017 by UGSI Inc. And with that, I will hand it off to Peter to kick us off.
Thank you, Sarah. Hey, everybody. Good morning. Glad to be here today. Next slide. So I want to give an overview, introduce you to the NAWI program, but also tell you a little bit about what we are shifting to in the second 5 years of our program, which is going to begin January 2025. Next slide. So NAWI is a research program funded by the Department of Energy. Keep tabbing. It's 5 years, $110 million, as Sarah said. Next tab. And in fact, we've just been renewed for another 5 years with an additional $75 million. Next tab. We also have a substantial involvement from at least the state of California, NAWI 1.0, and in NAWI 2.0, we're hoping to draw in more state-level agencies. Keep tabbing through. And basically, the idea is we have focused on lowering the cost and energy of critical water treatment and reuse systems. Next tab. And that idea is that we believe we can actually lower the cost and energy of desalination substantially. Next tab. Next tab. So our focus in the next 5 years of the program is actually cost competitive desalination and water reuse at regional, community, and even building scale technologies. And that's some of the stuff we'll talk about today. Next slide. One of the key points I want to raise is whether or not you're in the Better Buildings program or we are actually going to be partnering with Better Buildings, and we're going to be developing a whole range of programming and support so that we can advance some of this technology and get it into your plant so that you can see how it operates and see how it can save you money and water. Next slide. So let's just zoom out and say, imagine if we had a manufacturing facility that could reuse all the water it would normally discharge to the sewer or to the environment. Next tab. That would mean you'd have no discharge permits required at all because there'd be no discharges. You wouldn't ever have any gotcha chemicals that suddenly turn into a liability in your waste streams. There'd be no barriers to increasing facility productivity. There are no barriers to where a facility could be located. You could actually base manufacturing separated from water supplies. Next tab. And for your ESG goals, it would be ESG nirvana. So I know you listen to this and you think, surely, Peter, you must be dreaming. Next tab. But in fact, there are places where this is already happening. Next slide. So one of the things we've learned at NAWI is that water innovation typically occurs first in places of enormous water stress. And those are the places we can go to see what businesses and manufacturers are doing, and then understand how those innovations might propagate to the rest of the United States. Next slide. So I would like to introduce you to Phoenix, Arizona. Hot, dry Phoenix, Arizona is a thriving metropolis. And one of the key things that their manufacturing sector has had to do is develop tremendous innovations in water. There are something like 20 facilities across the Phoenix Metroplex that are doing ZLD, or zero liquid discharge water treatment, including some of the largest semiconductor manufacturers in the United States. It also has one of the largest inland power plants that has no liquid discharge. It uses 100% of the water that it is supplied. So Phoenix is a place where we can look. Next slide. But in general, thinking about water and manufacturing, water is a pervasive part of manufacturing. First of all, in many products, water is literally an ingredient, for example, beverages, et cetera. Next tab. It can be used as a physical fabrication tool. Water can be used as a cutting tool. It can be used as a bending tool. There are lots of ways in which water is actually used to physically fabricate products. It can be used as a chemical fabrication tool. We can actually immerse chemicals in water, things like dyes, and we can produce fabrics that way. Next tab. It also is very commonly used as a cleaning medium. Either plain water or water plus detergents is used to clean products, clean parts at many points. Of course, the most obvious way that we use water in manufacturing is as a coolant, either direct cooling onto products. You'll hear a little bit about that from Bob later on, or as a coolant for water heat exchange systems that regulate the temperatures. Finally, as a transportation vehicle, water is used sometimes to physically carry or convey materials like slurries and gravels. And so water is often a key part of many manufacturing steps. Next tab. But one of the challenges is it also is one of the facilities you have to have in every one of your buildings. And so a manufacturing site simultaneously is using water in a manufacturing setting, but also employees are using water around the various buildings. And so many manufacturing sites use water in multiple unit processes and in different ways. Next tab. Now, when we've talked about barriers to water reuse, and we've actually done research interviewing manufacturers about their interest or barriers to water use, obviously the first one that comes up is cost. Next tab. Water processing and reuse equipment has both capital expense cost and operational expense cost. And a cost-sensitive campus or manufacturing facility might be really concerned about taking that on. The other thing that we've heard is complexity. Plant managers have got a lot going on their plate, and they may not enjoy being responsible for another critical process in their facilities. And of course, the other final element of this is competing priorities. Manufacturing facilities have plenty on their plate as it is. And often a question we get is there a business imperative for this? Does this directly threaten the production of my products? Is this a nice to have or a must have? And realize that a lot of our manufacturing facilities around the United States were based specifically at a location because of the supply of water. And so it's often the case that, well, I've got water, I'm right by a river, things are okay. Maybe this is something I shouldn't worry about right now. Well, there are some challenges to that thinking as well. Next slide. As we've talked to manufacturers who've embarked on plant scale water conservation reuse projects anyway, the most common thing that we've heard is sometimes it actually is a business imperative. See Phoenix, you have places where water stresses affect stuff. Also, risk reduction has ended up being a critical factor that many operations managers and directors are thinking about. So supply interruption and curtailment of water can interrupt an entire manufacturing process. You can also have what I described earlier as what I call discharge or pollution risk. Even if you're operating under an NPDES permit, the potential is that somebody's going to get upset with something that's left over in your water. And then another one that kind of sneaks up on people is supply quality risk. We'll talk a little bit about that more. But a water conservation and reuse project at your site may end up being more valuable than you think. Next tab. And because when we've talked to managers, it turns out that water conservation and reuse projects, when they are green lighted, they're rarely justified just on a supply cost basis. They're often a combination of cost savings and one of these other value propositions I've listed above. Next slide. So let's talk about each one of these. Supply interruption and curtailment risk. Curtailment can come from events beyond drought. I know we think about like curtailment, problems during drought, but more often it's during some other event, a flood potentially. And municipalities commonly have stated policies that describe when and how they may need to curtail water. Next tab. National Renewable Energy Laboratory actually did a survey of all the water-related power plant curtailments that occurred in the United States and found that there are a wide variety of reasons beyond just literally a paucity of water supply. Secondly, production resiliency can be improved by on-site water reuse. So, for example, TSMC, which is building a major semiconductor fab in Arizona, Arizona is an attractive place for many reasons, and as they develop more efficient water usage at their plant, they actually feel like they can be much more flexible and resilient to changes in water supply in the Phoenix area. Next slide. So here's another one that often sneaks up on us: discharge and pollution risk. All of your plants, I almost certain everybody is operating in full and complete compliance with your NPDES permit, right? But that doesn't prevent you from coming under scrutiny. Next tab. Because discharges in our water, especially for older NPDES permits, might still be seen by some in your community to be problematic. Next tab. And the new and emerging contaminants outside of the regulatory framework can really be a nightmare. Next tab. Of course, I'm talking mostly about PFAS, the perfluorinated substances, which are in a wide variety of products and manufacturing settings and are now in your discharges. And also, next tab, the potential that microplastics, which can be a waste product, either directly from your manufacturing process or indirectly as the products you've made break down in the environment. These two emerging contaminants can give the community real concerns. And so this is another factor that causes water-using manufacturing sectors to consider how they might modulate their water discharges or reuse some or all that water. Next tab. The final one is kind of sneaky. Supply quality risk. Many manufacturing sites rely on raw water supplies, and even those raw water supplies can be subjected to very big changes in composition and temperature. And this can have a huge effect on product quality, product consistency, and unit process reliability. It turns out that many of these curtailments that NREL mapped in power manufacturing in the United States came not because of a lack of water supply, but the fact that the temperature in the water they were using as a coolant was rising to the point where they couldn't discharge and keep below their permit. Another thing that, here's a funny story. A optics manufacturer in Connecticut uses water as a course of polishing and cleaning their optics. And one summer, they found out that they were seeing pits, microscopic pits in the surface of their glass products. And they didn't know what was going on. Their abrasives hadn't changed. Nothing had changed. And it turns out that the municipal water company that had been supplying them water for decades subtly changed the chemistry of the water, and that reacted with some of the abrasive products they were using and produced deleterious manufacturing steps. So this is why some manufacturers actually treat their municipal water before they use it in some processes. So for example, beverage manufacturers, no matter where they are, their first step in making a beverage product is to actually take the municipal water, strip out everything, and then remineralize it with a known quantity of minerals to achieve the right starting ingredient for their product, which is, of course, things that we drink. Next slide. So semiconductor manufacturing is an extreme example of this requirements for water. This is a specification, a typical specification for what we call ultra pure water. And any of you who've looked at water or water treatment, look at the units of measurement in some of these things. Online particles, less than 200 particles per liter. Silica, 50 nanograms per liter. These are astoundingly small and minute quantities of contaminants. In fact, this water is so extraordinarily pure. If you actually were asked to taste it, it would actually taste terrible because it has no minerals in it whatsoever. Next tab. This is one thing that I want to emphasize, is that water treatment and water production, we can produce water tailored to any specification that's optimal to manufacturing. It's often the case that manufacturers may be getting by with water that's not quite the right chemistry for the processes they're using, but it does take a price, and sometimes that price is worth paying. Next slide. So one other thing that we're focusing on in the NOWI program in the next 5 years is what's called premise scale reuse. Some manufacturers are actually utilizing their campuses to demonstrate water reuse systems for the entire campus. Next tab. And San Francisco is an example of a city that is now mandated that new buildings greater than 100,000 square feet may not use drinking water, that is to say city water, to flush toilets or to wash clothes or to irrigate landscape. Let's take a look at this closer. As I said, some manufacturers, next tab, some manufacturers are already implementing these campus scale water reuse systems. This is the campus of Meta, formerly known as Facebook, in Menlo Park, California. They have installed a campus-wide water reuse system. It takes rainwater and the wastewater from sinks and drains, et cetera, and reprocesses that water for toilet flushing and irrigation. Next tab. Similarly, up the road in San Francisco, the Salesforce building is operating with its own premise scale reuse systems that enable them to capture and reuse all that gray water and use it back in other processes. Next tab. Of course, the final frontier is with this innovation in these few locations like San Francisco, you're beginning to see the emergence of truly packaged systems that can do entire premise scale water reuse. This is an example of one by a company, Epic Cleantech. This system gets installed, takes all the gray water, can reproduce high quality water for production for various applications. In fact, you can tailor the water like a barista at a coffee shop. You can tailor the water for different applications. Next slide. So a couple closing points before I hand it off to Bob. Industrial water reuse in the manufacturing facility scale is coming. It's already present in some locations, but it's certainly going to come to more locations. Reliability is increasing and costs are decreasing. And this is coming because at the current pace, conventional water supply and discharge reliability may actually be decreasing, and costs of conventional water supply may be increasing. So these are the reasons why this is happening. Also, NOWI and Better Plants is planning a vigorous collaboration over the next 5 years. Next tab. We're going to be holding a series of webinars like this one in partnership with Better Plants and Better Buildings. And we're going to try to bring you some of the information on the frontiers of water reuse and some of the technologies that are available to you. The NOWI program is also looking for partners in the manufacturing setting. We are going to be having opportunities to fund pilot projects to demonstrate advanced water treatment and reuse systems in manufacturing facilities. Next tab. And there are also some other partners in the water sector who are funding the demonstration of trials and new products to save more water and save more money. All right, so that's it for me. Next slide. I want to just alert you that there's an upcoming conference organized by the Water Reuse Association. It's the first time they've had a dedicated conference on industrial water reuse, November 19th through 21st in Indian Wells, California. Now he's certainly going to be there. If you or a member of your team are going to be there, please reach out and find me. We'd love to talk about how you're using water at your facilities. And with that, I want to go to the next slide and just say if you have any questions, you can reach out to me directly at pfisk@lbl.gov, or you can go to the NOWI website at www.nowihub.org. It's free to join the NOWI Alliance, and then you can get all this information about how we hope to advance water reuse technologies in the future. All right, Sarah, thanks very much.
Yeah, thank you to Peter for that fantastic presentation. A quick reminder to our audience to send in any questions you have at www.slido.com with event code #DOE or #DOE. We look forward to answering your questions at the end of the session. And now we will hear from our final speaker, Robert. Robert Urich is a chemical engineering graduate from Purdue University and Southwest Chicago suburbs native. He has spent 15 of his 22 years at CertainTeed Oxford as an environmental coordinator, focusing on environmental compliance and contributing to various sustainability and process improvement projects. Robert, take it away. Thank you so much, Robert. So next we're going to move on to Q&A. So if you haven't already, please do join us over at slido.com with event code # or #DOE to submit and upvote questions. So we do already have a few questions going on, and I think
yeah, I've been hard at work trying to answer some questions as they come in. Hey, Robert, that was a great talk. Really successful project. Congratulations.
Thank you, Peter.
Yeah.
Awesome. Well, yeah, why don't we jump into I see that Peter, you've been going through and answering, but since we've got some upvotes on these, um actually, yeah, is there something that one or the other of you really want to focus on right away? Since
Yeah,
Peter, you
Robert,
yeah, go
Robert, let
ahead.
me ask you, let me kind of start by maybe interviewing you directly. So what was the what were the reasons why the plant pursued? Let's review some of your comments about why did the plant pursue water reuse anyway? Was it first framed as a cost savings, or was it framed as a other set of values?
It was framed more of the corporate goals of the 2025 reduction of 50%. And we knew that we could some cost savings, but we knew that wasn't going to fund the project with the ROI of the corporate requirements.
Did you have any local feedback or encouragement from either your local water utility, et cetera, with respect to embarking on this project? Or did the project take place kind of completely separate from the dialogue with the water supplier or the
Completely
sewer supplier?
separate. We did have some discussions with the sewer because we actually are building a MAP plant here on site, and actually it helped that we were decreasing our discharge to give them some of that volume of water that we had. So it actually helped. Another reason that we weren't expecting. Like I said, expect the unexpected. You never know what's going to happen in a project.
Yeah, I wanted to clarify that. You said in the end that your sewer costs went up, even though you had smaller district. Can you explain just
Well, no,
repeat
the
that
cost
again?
per gallon went up.
Cost per gallon went up. Okay.
Sorry, cost
Yeah.
per gallon went up from 1 cent to 10 cents.
From 1 cent to 10 cents.
In just a couple months, they just started charging us more.
That wasn't because of you. They just were charging
No,
everybody.
they just were charging more. Yes.
Well, so in other words, you had, I don't know if you read the tea leaves, but that was a project got a lot more valuable because
Yep. Like I
sewage
said, it went
discharge.
from about a 75 to $100,000 project up to a $300,000 savings.
Nice, nice. Well, you talked about expect the unexpected. Um, what were some of the unexpected or issues that arose as the operators were getting used to the water, operating the water system?
We had to clean the pipes a little more frequently. They stopped up one time without them realizing it, and that kind of had some downtime that was unexpected, but it was because they didn't keep up with the cleaning and they realized
Mm,
they had to do a little cleaning.
yeah.
Um, we had some pumps that went cavitated because the water system was reused so much, the water dropped level so much that we
Mm,
had to make adjustments to pipe levels and programming because of that. Those are the two things I can think of.
yeah. Great. Great. Well, that's my interview question, Sarah. What do we have from the audience?
Yeah, we've got those are great questions. We've got questions rolling in online too. And remember, folks, you can also upvote questions. And Peter, you've done a great job of answering some of these as they've come in live. I did want to spotlight one that, even though Peter, you gave an answer already briefly, but it's been upvoted the most times. So I just wanted to spotlight it here. What's a good resource for learning about state and local regulations on water reuse? I know many areas differ on the restrictions of using gray water.
Yeah, so the Reuse Explorer. This is a great resource that the EPA has, and we have used it a lot because the reuse rules around the United States are actually changing dramatically. A number of states are right now actively working at state level regs. So the Reuse Explorer, which is available on the EPA website, is a great resource to go to. Also, I'll say that the Water Reuse Association is a nonprofit that focuses on advancing water reuse. They have regional chapters. And so if you don't know anything about the Water Reuse Association or the chapter in your part of the country, definitely check them out.
Fantastic. Thank you, Peter.
Can I ask
Um,
Bob a question about that? So Bob, how did you learn about, reuse? Are you, for example, connected to a Water Reuse Association chapter, or how did you guys first learn about the opportunity?
Now, when I got here, they were doing some water reuse on lines 1 and 2. And over the years, it's gotten more. And so we just kind of fed on what they were doing and improved on what was going on.
Okay, great.
Now, I did just answer a question that I did want to highlight. about evaporative cooling and the reuse of that steam. We are talking about it. We don't know how practical that's going to be to collect the steam. But one of the things we do know is we are evaporating over 100,000 gallons a day on these hot summer months like today. So really the only way to get to our goal is to do something like that. So we're not sure how practical it is. We have to look into that.
There are a couple of other questions that have been submitted through the portal that you all haven't had a chance to answer yet. So one that's been upvoted is what are the most common / best uses for RO reject water in a bottling facility?
Yeah, well, most often people are, if they're permitted to do so, they're just discharging that brine back into the sewer system. We found that in some cases, one of the areas of research that we're doing right now in NAUI is brines, of course. When you desalinate water, you take water with some salt and you squeeze out fresh water, but you're left behind with a small amount of even more concentrated salty water we call brine. And so that is a waste product and can be discharged. But it turns out that the salts that are in that brine actually can be recombined to make chemicals. So in fact, we're doing a project right now demonstrating with K. Bailey Hutchinson Desal plant in El Paso, Texas, that we can take the concentrate, the brine material that they reject, and we can electrolytically separate it into acids and bases. And those acids and bases can be used back in the water treatment process itself. So this is the area is called brine valorization, or how do you take something that's a waste product and turn it into something valuable? It's an area of active research right now, and definitely if you're interested in learning more, you can come to the NAUI website at nauihub.org, and we have a couple brochures that talk about that project.
Great. Another question we've gotten. So for premise scale systems, what, if any, impact studies should be done on downstream water flow impacts? If rainwater is captured and enters a processing loop that diverts it from the local river, what is the long-term impact?
Yeah, Ian, really interesting question. So first of all, there's a little bit of interesting history here you probably know, and that is in the state of Colorado, it was actually illegal for you to take the rainwater off your roof. Because in the state of Colorado, water rights required that the people who owned the water in the watershed had rights to all the water, even the water that fell on your roof. Now, state of Colorado changed that because that sort of ends up creating a perverse disincentive to harvest rainwater. So they've changed that law. But one of the concerns was, what do these diversions of runoff do to our local ecosystems? Well, it turns out that for starters, the amount of water that gets diverted in a typical rainwater capture system is a vast, vast small fraction of the total water that lands over a given area. Most of the water that lands on a given area will soak into the ground and through groundwater or percolation either run below the ground or run back into a river. One of the key concerns, especially in arid parts of the United States, are the amount of impermeable surface. So not just your roof, but also your parking lots and these impermeable surfaces. Because we are seeing more and more violent storms with more and more precipitation happening more and more suddenly, these areas of high impervious pavement are a real problem because they can promote flash floods. So some communities are actually encouraging the inclusion of what's called permeable systems into new developments. So, for example, in Los Angeles County, there's a new measure that actually taxes a new project for all the square footage of impermeable space they create. So they'll tax you, they'll measure the area of the roof and they'll measure the area of the parking lot, and they will issue a tax. However, if you install permeable pavers and percolation structures called French drains, they'll actually give you a rebate. So it's been a really great way for developers in Los Angeles County to be incentivized to make their properties more porous, more permeable, so that rainwater falls and soaks into the ground. And overall, that's what we sort of need to do everywhere is make our built environment a little bit more permeable so that we don't have these vast amounts of runoff, which can lead to flash flooding, which can lead to a lot of the damage that we see in today's news.
Thank you so much, Peter. Another question came in about certainteed. So did the corporate edict allow for no ROI requirement? And did corporate provide the funds in that case?
Rochelle, you listen to this one. Do you want to? We did not get funds from corporate on this. There are some funding available for projects, but I don't remember. It's been so long. The project was only $135,000. So I think it wasn't a horrible ROI with about the $75,000 we were saving. But if Rochelle's still on, she could probably answer some of that question.
Yes, I'm on here. Go on video. Hi everyone. So what Robert said is exactly correct. This project was not funded by corporate, but we do have corporate funding for sustainability projects that allow for longer ROI and payback periods. So good question.
Yeah, we always get a lot of questions and discussion topics about financing projects in better buildings. So thank you, Robert and Rochelle. Rochelle is, of course, another representative of Saint-Gobain who joined the webinar today. So thanks for pinch hitting on that one, Rochelle. Awesome. So just still going through some of our questions. I know this is one, oh, here, we have one more that you all haven't answered yet, or maybe we don't. Yes, here we are. So we are considering changing to air-cooled versus water-cooled air compressors. Is there a better opportunity to use recycled water for the application? Need to balance water reduction / power reduction. And then that person also, or maybe it was someone else, it's all anonymous, added in, we use a heat exchange system from IMEC to preheat domestic hot water and cool our compressors. So anything you all want to add to that?
Well, I mean, for starters, we're looking right here at the way we want the Better Buildings, Better Plants community to operate, where people are beginning to share like advice with each other. So right on, everybody. In terms of that, I mean, that question you ask, I don't have a direct answer to you, but it immediately strikes me that it would be a great example of an analysis that some of our team at the national labs could do for you, where we could actually look at that cost payback relative to the amount of energy, increased energy for the air cooling versus water savings, et cetera. And Sarah, I just would say we'll invite that person to follow up with us, because that's an example of how you can give us good questions, and then we can come back to the whole community with better answers.
Yeah, absolutely. And I think we've got time for one more question, but I will say we're going to close out and provide some contact information. And so, when Peter says reach out with that question, he means it. So yeah, just one final question I wanted to make sure we addressed. I know we have a lot of multifamily folks on the call today from our polls. And Peter, you did a brief answer to this, online. But I wanted to address it live. If there's anything you wanted to add, how can water reuse technology be developed in multifamily units and apartment complexes?
Yeah, well, so for starters, one of the things I pointed out is that because when you do reuse at the scale of an apartment building, you are now talking about additional plumbing, best to be done on new projects, harder to do as a retrofit. That being said, there's some really interesting technologies out there. There are a set of recycling shower systems, Sarah, where you can actually enjoy a half-hour shower and 80% of the water is recycled. So you can sing to your heart's content. And not only that, but these showers are high volume, like 3 gallons per minute. And so there are some really interesting ways that a retrofit actually within the bathroom could result in some really enjoyable savings. I will go back to the issue of like multi-unit apartments. So when San Francisco first passed this change to the building ordinance, there was a lot of consternation on the part of the real estate community, because they were like, what is this unfunded mandate? What crazy thing are you making me do? My tenants are going to hate it. But nevertheless, the first few projects went in, and then they discovered something amazing. The tenants actually loved it because the building was like LEED platinum, because they had such water efficiency. And so it actually, the real estate community went from kind of fearing this thing to loving this thing, because it's a relatively economic way to really boost the overall scoring of your project in terms of sustainability metrics like LEED. So and then the other thing is that in the East Coast, they have had some buildings with premise scale reuse operating for years. And during Superstorm Sandy, when it was coming up the coast of New Jersey and New York, it wiped out all the water supplies for many of those communities. And the only buildings that still had water available were the buildings that had premise scale reuse. So another interesting rationale for property owners and managers to think about is my building might end up being more resilient. And it may actually be a feature that my tenants might like to see, as opposed to a cost that they have to bear.
Yeah, that's great. Thank you, Peter. And I think if we do it rapid fire, we got one more question coming in before we close up. As sewer charges are often tied to water usage, are you seeing more usage of sewer meters to prove you aren't discharging to the sewer so that you're only charged for the amount of wastewater you discharge?
I don't know, man. Bob, do you know answer that question?
Well, I know when I started here 22 years ago, we already had a sewer meter because we, like I said, we'll bring in 100,000 gallons on a hot summer day and discharge 4,000 gallons a day. So, depending on how many people are here. So we obviously, someone before my time realized that had to be done, and we had to work with the city to get that sewer meter. So we're only charged with what we discharged.
It does seem like it's a great recommendation. Awesome. Well, thank you all so much, Robert, Peter. This has been fantastic. Really appreciate the live question answering, and really appreciate everyone who has submitted questions as well. I'm going to go ahead and close up with a couple of final remarks for our remaining attendees. Thank you again, everyone. This webinar is part of the Better Buildings 2024 summer webinars lineup. We have a great collection of presentations every Tuesday, and please visit the Better Buildings Solutions Center to learn more, register, and see what's coming up. Next slide. Our next webinar is on July 2nd, titled Fail to Plan, Plan to Fail, How Emissions Reduction Planning Helps Partners Meet Climate Goals. Highly recommend. This can really help you explore the benefits of creating an emissions reduction plan and learn firsthand from our partners that have already developed and leveraged these emission reductions plans to make strides toward reaching organizational climate goals. And then final slide, once again, thank you so much to our panelists for taking the time to be with us today. Feel free to connect with our presenters directly with additional questions, or if we couldn't get to your question during this Q&A,